Hi everyone. In our previous videos, when we started sets, we looked at situations where we listed the elements of a set, or we listed the members of the set. Take for example, we had situations where we had a set of, say, A, and we listed the elements as, say, 2, 4, 6, 8, 10. In this case, we have listed the elements of this set A. We listed the elements or the members of set A, okay? What about in situations that we do not list the elements, but rather we used algebraic notation or algebraic approach? How do you interpret such algebraic notation? Let us take a look at an example in that. We have this whereby you have been given this algebraic notation. How do you list out the element of this? The first thing is you need to know how this can be read. So this is read as A is a set of X, because you have the brace that tells you it is a set, and then you have X here, it is a set of X, such that X is an even number between 2 and 14. Again, A is a set of X such that X is an even number between 2 and 14. So now, how do I list the elements of these sets? I have A equal to, put the brace. We said X is an even number between 2 and 14. That means 2 and 14 are not inclusive. That means the even numbers will be between 2 and 14. Okay, what are even numbers? They are numbers which, when divided by 2, will not have a remainder, right? Now, what are the even numbers between 2 and 14? You will agree with me that it's going to be 4. You start from 4 because 2 is not inclusive, because it says between 2 and 14, which means 2 and 14 are not inclusive. Okay, so I have 4, 6, 8, 10, and 12, and 12. 4, 6, 8, 10, and 12. Okay, so that is how you interpret such algebraic expression. Again, this means A is a set of X such that X is an even number between 2 and 14. And now we have been able to list out the members or the element of this set A. Okay, very good, guys. I hope you are getting this concept right here. Let us take a look at another example right here. You have also been given this expression, okay, and now you want to list out the elements. You need to first of all be able to read this notation. Okay, now how do you do this? Okay, now this means that, or it can be read as, say, B is a set of X such that X is an integer. X is an integer, okay, which is greater than or equal to 3, and less than or equal to 9. Okay, which you can also say it lies between 3 and 9 inclusive. How do we come about that? Let me take some few minutes to explain how you interpret this expression right here. First of all, let us interpret this first part that says 3 less than or equal to x. If you say 3 less than or equal to x, what does that mean? I can interpret this the other way around and say it means x is greater than or equal to 3. I can flip this sign because it says 3 is greater than, it says 3 is less than or equal to x. This also means x is greater than or equal to 3. So that means because of this sign equal to, that means x is going to start from 3. X is going to start from 3. Okay? Now, this other part that says x is less than or equal to 9. If x is less than or equal to 9, okay? So that means x can be less than 9 or it can be equal to 9. That means x can stop at 9. Okay, so that means if I'm going to list the elements of b right here, okay, it's going to be, remember we said it is an integer, right? And here we already established that x is going to start from 3 because of this equal to. So it's going to be 3, 4, 5, 6, 7, 8, and 9. Very good, guys. Which is why we said 3 and 9 are inclusive. They are inclusive. So x is greater than 3. That means it can start from 4, right? Because it's greater than 3. But then you also have sign of equal to. So that means x also is equal to 3. That means I can start from 3. Okay. Now here it says x is less than 9 or x is equal to 9. Because of equal to, that means I can stop at 9. That means 9 is inclusive. Okay. Unlike this first example that says even numbers between 2 and 14. Between means that 2 and 14 will not be included because there is no word that says inclusive, right? You must always watch out for that word that says inclusive, right? So that is not included. So we are not going to include 2 and 4 in that. I hope you understand this concept, guys. Okay. Let us take a look at another example in this for you guys to better understand these concepts. Okay. Here you have a set E. You have this E. Okay, is a set B. Is a set of B such that B is an integer. B is an integer. Again, E is a set of B such that B is an integer. Okay, and B is greater than 1 and less than 7. Okay, so if you look at this sign, 1 is greater than is less than B, less than 7. So this part right here, which says that 1 is less than 7, 1 is less than B. Okay, 1 is less than B simply also means that B is greater than 1, right? because 1 is less than b means b is greater than 1, right? So that means b is going to start from what? From 2. Okay, what about this part that says b is less than 7? If b is less than 7, remember it says it's an integer, right? If b is less than 7, where is it going to stop? Is it going to get to 7? No, because there is no sign of equal to. Because it's less than 7, it's going to stop at 6. It's going to stop at 6, okay? So that means for me to list out the element of E, it's going to be this. Put your brace, okay? Remember, 1 less than b means b is greater than 1. That's going to start from 2. Then I'll go ahead and start increasing. 3, 4, 5, 6. Am I going to include 7? This says b is less than 7. There is no sign of equal to, right? That means 7 is not going to be included. So that means the last element is going to be 6. And then I'll close my bracket. Okay? I hope you guys understand this fundamental concept. Now, by now, you should be able to interpret algebraic set notation in set. Again, this means E is a set of B. E is a set of B such that B is an integer and B is greater than 1 because of this sign right here. 1 is less than B means B is greater than 1, and B is less than 7. So that means B is greater than 1 means B is going to start from 2, and it is less than 7 means it's not going to get to 7. It's going to stop at 6. Okay, that is that about that. I hope you guys understand this fundamental concept. Before I leave you guys in this class, take note, this sign is less than. This sign is less than, okay? And this sign is greater than, okay? Okay? This sign is less than or equal to, okay? And this sign is greater than or equal to. This is less than, this is greater than, this is less than or equal to because of this sign, and this is greater than or equal to because you have this. All right, guys, I will see you in the next class where we are going to be looking at union and intersection of sets. If you are new on this channel, I will encourage you to subscribe to this channel and click on the bell to turn on your notification so you don't miss any of our videos. All right, guys, I'll see you in the next class. Bye.